Acids are those substances that dissociate H plus ions in aqueous. What does it mean? That, for example, if you are having acids, okay, acids, when react with water or they are added to water, they produce H plus ions. They produce H plus ions. Okay. So actually, like for example, we have HCl, hydrochloric acid. Okay. We add it to water. So this water, in water, this HCl is going to produce H plus ions, and H plus ion does not exist independently. This H plus ions get attached with the water molecule, and when it attach with the water molecule, it form like this, and this is called hydronium ion. What we called it? H3O positive. H3O positive, which we called it, okay, which we called it hydronium ions, okay, which we called it hydronium ion. Got it?
Yeah. Basically, it gains the ion. It becomes.
Okay, so that we called it hydronium ion. So acids are those substances that dissociate, that produce H plus ions or hydronium ion in water when added to water. If they are not able to produce H plus ion, they are not characterized as acid. So it is a hydronium ion that is responsible for the acidic properties. Okay,
Okay.
understood? Next,
So the
basic.
H plus ion is responsible for the acidic properties of the acid.
Okay, okay. So H plus ion is responsible for basic properties. Next one is, if I'm saying that, if I'm saying that acids when react with base, okay, or if I'm talking about the base, so base are those substances which when added to water, they produce OH negative ions. Like for example, NaOH, when added to water, it will gives you OH negative ion plus Na positive ion. So if they are producing Na positive ion, so we'll consider it as, sorry, OH negative ion, will consider it as base. So it is the basic property shown by this one. Understood?
Yeah.
Basic property is shown by this OH negative ions. Understood?
Yeah.
Now moving further, acidic property is shown by H plus ions and basic properties is shown by OH negative ion. Now what
Okay.
is, according to the Arrhenius, there are two scientists who give the different definition of acid-based definition. Acids are those substances that produce H plus ions in aqueous, and base are those substances that produce OH negative ion in water when added to water.
Okay.
And then another scientist named as Bronsted-Lowry, who said that acid are those substances that donate H plus ions, that produce or that donate H plus ions. Understood?
Yeah.
And bases are those substances that accept the H plus ions. That accept the H plus ions. Understood what I'm saying?
Yeah.
That accept the H plus ions. So if he is not in the Bronsted-Lowry, there is no concept of OH negative ion for the base. If it is donating H plus ion, it is acid. If it is dissociating H plus ion, it is base. Okay, understood?
Yeah.
Yes or no?
Hmm?
So this one, so start writing the definition for the Bronsted-Lowry, that Arrhenius concept: acid that dissociate OH negative ion, base that dissociate OH negative ion. Bronsted-Lowry concept: acid are those substances that donate H plus ion, bases are that accept H plus ion. Don't write this one. Write it fast.
Okay, I finished writing.
Okay, next. Now, acid when added to water, it will give you hydronium ion, NCl minus ion. Similarly, here, if you add NH3, NH3 is ammonia gas. When it added to water, it form ammonium ion, NH4 positive. It accept the H plus ion from ammonia, NH ion from ammonia, and then it result NH4 positive and so it is accepting the H plus ion. You see here, it is accepting the H plus ion. So that's why it is a base. Acceptance of H plus ion is base. And
Yeah.
water is giving H plus ion here. So it is an acid.
Okay.
Okay.
Yeah, I got it.
So note it down.
Okay, I finished writing.
Okay. Next one is now if I'm talking here is that glucose, which is these glucose, like it is in your examination is going to be that glucose and ethanol are not characterized as acid. Instead, they have hydrogen ions. So if the question comes in examination that why do glucose and ethanol is C2H5OH, ethanol, they both have OH negative ion, or you can say OH ions or H plus ions, you can consider it. Here it also have H hydrogen atoms, but they are having hydrogen atom, but they are not characterized as acids. So can you have any idea why it is not? So why it is so?
They're not comprised of acids.
It is very simple because ethanol does not contain any. We can simply say that because glucose and ethanol in water do not dissociate in their H plus ion. I mean, they are not going to dissociate. When you add it, they are not going to dissociate their H plus ions. So it will not be able to consider as acid. This will not be considered as acid. Okay, because acidic properties is just due to the H plus ions. Okay, of acids. If someone is not dissociating any substance, that when you add it to water, it is not dissociating the H plus ion, it is not considered to be as acid. Okay, so first you have to write the question, then you have to memorize it, and then you have to write down in your copy. So glucose and ethanol are not characterized as acid. Instead, they have hydrogen ions. Reason is because both glucose and ethanol in water do not dissociate their H plus ions. So it will not be considered as acid because the property of acid is shown by H plus ions. Okay,
Okay.
understood?
Yeah.
So first you have to memorize this question. Sorry, answer. Then you have to write it. First you need to tell me. Then I will listen it from you. Then you have to start writing.
Okay.
Note it down. Note the question fast. Only question.
Okay, I finished writing the question.
Okay, so memorize it fast. Done? Memorized?
Yeah, I memorized it.
Okay, write the answer.
I finished writing the answer.
You done? Okay. So check whether if you have done some mistakes.
Yeah, I wrote the answer correctly.
Okay, let's move further. So if the question comes in examination that, for example, you have a dry litmus paper and dry SCl gas, okay, and you pass SCl gas to dry litmus paper, okay, then if it is blue litmus paper, it should change its color to red because when acid comes in the contact with the red blue litmus paper, then it should change it to red. But here there is no change in color is observed. Why?
No
If
change
you
in
dry
color.
SCl gas and dry litmus paper and you pass the dry SCl gas to blue litmus paper, it should change its color to red, but it is not changing its color. Can you tell me that why it is so? Why it is so?
Because it is maybe neutral. Like,
It is just very simple because it is the water that is helping in dissociation of H plus ion from HCl gas. And it is the H plus ions which are responsible for the acidic properties. If there is no H plus ion, no water, no H plus ion, no acidic property. However, if we moist the litmus paper, blue litmus paper, and we moist it and bring it again to the dry HCl gas, then since the water molecules are present in the litmus paper, so it will help in the dissociation of H plus ions. And then this time, in case of blue litmus paper, it will change its color. Okay,
okay.
understood?
Yeah.
So note it down that why do the color of litmus paper do not change uh, when dry HCl gas is passed through it, and if the litmus paper is moist, then it changes color to red. To change it, then it change its color to red. Note it down fast.
Yeah, I finished writing.
Okay. The color of the litmus paper do not change because, can you tell me? Can you read the question? Why does it do not change?
Okay, so
Read the answer. The voice is not coming. Why your voice is not coming? Speak something.
um,
Yeah, it is coming. Can you tell me the answer? You finish writing. You
so it doesn't change the color because
why it does not change? You said you finished writing. You write the answer. So read the answer from the
I
notebook.
mean I wrote like half of it.
So as much as you wrote, read it.
Okay.
Read it. You didn't write.
Yeah,
Why are you lying?
because I write slowly and you keep telling me to write fast. So
So why you said I finished writing?
I don't know.
Read any statement that you have done. Uh, can you tell me that why glucose is not characterized as acid and base? Can you tell me?
Yeah, yeah, glucose C6H12O6 and ethanol C2HSO H5OH are not characterized as acids. Instead, they have hydrogen atom because both glucose and ethanol do not dissociate their H plus ions in water. So it is not considered an acid. The because the property of acid is shown by its H plus ions.
Write this. Write this question first of all, and then write the answer. The color of the litmus paper do not change because there is no water present. Take your time. It is easy question, okay? But the
Okay.
questions are important. That's why you need to write in your notebook. Because there is no water present, which help in the dissociation of H plus ion. Because water help in the dissociation of H plus ion from HCl gas.
Just writing.
Done?
Yeah.
Okay. So here we have this one, that however, the same part continues here, that however, if the moist paper is taken, then H plus ion dissociation take place because of water in the moist paper, moist litmus paper, and hence the color of the litmus paper change. So note this yellow colored portion also. Done?
No, 1 second.
Okay, okay.
Okay.
Here we have some question over the topic that we have done. Question number 16. What should be the answer for question number 16?
Okay. Option number B is the answer.
Option B.
Yeah, because when you add that small amount of acid and water,
Yes. Ionization and dilution take place. Good. Question number 27.
maybe it's option number C.
Option number C.
Yes.
It ionizes the solution and it forms hydronium ion due to the combination of hydrogen molecule. Correct. Question number 29. Question number 29.
Yeah, oh, 1 second. Okay, for this one, I'm not able to figure it out.
It is the same question that we are doing. Which of the followings are present in the dilutions of aqueous solutions of hydrochloric acid? So when you add hydrochloric acid, then hydronium ion and chloride ion will be there. Okay,
Yeah,
when you
there
are
would be.
having, let's suppose, just sharing your screen again. Okay, and if you add hydrochloric acid to water, then what would happen? It will gives you hydronium ion, H3O positive, because the H plus ion will be added to this water molecule, plus Cl minus ion. Understood?
Yeah, I understood. Okay, yeah. That's why we're getting H3.
Next is a question comes in examination that ammonia NH3. It does not contain any OH negative ion. It has hydrogen ion, but it does not contain any OH negative ion. But still it is characterized as base. Why it is characterized as base? It is
Does it
characterized as base when added to water. When added to water. So can you answer me why it is so?
is it because it accepts the hydrogen plus
Yeah,
ion?
it accepts the hydrogen ion from water and form hydronium ion and OH negative ion. And any substance that accepts the hydrogen ions, that is considered to be as base. It runs blue litmus, red litmus to blue. Okay.
Okay.
So the question going to comes, ammonia do not contain any OH negative ion, so it is characterized as water. Sorry, as base in water. So you have to write the question first, and then you have to start memorize the question, answer of the question, and then you have to write down. Okay,
Okay.
write down the question first.
Is that equation NH3 plus H, is that also a part of the question or is that like the answer?
Yeah, it is from the answer question.
Okay. Okay, I memorized it.
Okay, start writing.
I finished writing the answer.
Okay. Next, we are talking about the acid-base indicators. So what are acid-base indicators? Acid-base indicators are those substances that changes their order or smell in acidic or basic medium. Like some indicators are they change their color or some change their smell. Those change their smell are called olfactory indicators, and those change their color are called normal indicators. Okay. So
Okay.
what are indicators? Indicators are those substances that changes their color, smell, or odor when added to acidic or basic medium. Okay. So just have a look of, just try to memorize it because it is very important that the color of litmus paper is purple, neutral is purple, red in acidic medium, and blue in basic medium. Methyl orange, orange, then red in acidic medium, and yellow in basic medium. Phenolphthalein colorless in neutral, and acidic medium, and pink in the basic medium. Try to memorize it fast, and when you're done, please let me.
Only the table, right? Not the
Only
definition
the
or
table and
something.
the definition is very simple. You can memorize the definition by just reading one or two times.
Okay, I'm done memorizing it.
You're done memorizing.
Yeah, it's not that hard to memorize it.
Okay. So start writing.
Okay, I finished writing.
You done the definition only. The table also.
Yeah, the table too.
Okay. Tell me the color of phenolphthalein in acidic medium
It's colorless.
and basic medium,
It's pink.
and what's the color of litmus in neutral medium
It's purple.
and in basic medium.
It's blue.
Okay. Now we shall be moving towards the strong acid and strong base. What are strong acid and what are strong base? Strong acid are those acids that completely dissociate. When you add it to water, they completely dissociate the H plus ions. Like for example, you have HCl molecule, 5 HCl molecule you added. So everyone is going to produce their H plus ion. They will get dissociated. Okay, they will produce H plus ions as money. But weak acids are those acids that incompletely dissociate. Like you have CH3COH. Most of them will remain undissociated in their original form. Some of them are going to dissociate like this. Okay.
Okay.
So some of them are they partially dissociate. So they are called strong weak acid, and those dissociate completely. They are considered to be as strong acid. Okay. So you have to memorize the name of these strong and weak acid. This is HCl is strong, H2SO4 is strong, HNO3 is strong acid. And weak acid is CH3COH, which is called ethanoic acid, H3PO4, phosphoric acid, acid, H3PO3, phosphorus acid, acid. So memorize it fast, the definition.
The definition plus the examples.
Hmm?
The definition plus the examples, right?
Yeah, you memorize it.
Yeah, I'll memorize it.
Okay, memorize it fast. You done?
Second,
Those assets that which dissociate their H plus ion completely. Means complete dissociation is taking place. There's a strong asset.
I learned. I just have to learn the examples.
And that partially dissociate or incompletely dissociate, they are weak acid.
Yeah,
Okay?
the weaker.
Memorize this, only the name of this weak acid and strong acid.
Only the name, not the.
Carbonic acid, H2CO3, weak acid, carbonic acid.
Only the name, not the.
Carbonic acid. Okay.
Okay.
Done?
Uh, 1 second. Let me just go through one.
Just complete.
I memorized it. Memorized it.
Okay. Start writing.
Okay. Okay, I finished writing.
Okay, let's start. So here is Zoha that how do H plus ions. So when a strong acid and a strong base. Now there is one type of question is there. Okay. Similarly, we have a strong base. What are base we're going to study simultaneously. Okay. There is one thing remaining that what are olfactory indicators? Olfactory indicators are those indicators that changes their smell when added to acidic or basic medium. Okay. And like for example, clove, onion, vanilla essence. Okay. So these are the olfactory indicator that changes their smell when added to acidic or basic medium. Okay. Okay. And natural indicators are those indicators that are obtained from plants, trees, or some natural substances. Okay. Like turmeric, rat cabbage, litmus, they are also all natural indicators. Okay. Understood?
Yeah, understood.
So, do you know everything about this one? Just write the olfactory indicators.
Okay. Okay, I finished writing.
You finished writing. Okay. Okay. Let's have the questions over this topic. As you know, one thing is that it is the more the H plus ions, more will be the acidic character. And you know, if I'm saying that HCl and H and CH3COH, this is strong acid
Yeah, that's a strong one. The
and
other one is
this
weak.
is weak acid. So weak acid will produce less H plus ions, less concentration of H plus ions. And strong acid will produce high concentration of H plus ions. Okay, so let's deal with the question. Uh, Okay, question number 8.
Okay. Mm. Option number C is the correct option.
Yeah,
The hydrochloric acid, it's a strong acid. So
the hydrochloric acid. Okay, and the another one is then which is the correct option in this one? Question number 8. A.
oh, A is the correct one.
Yeah, A, because water is less acidic, then acetic acid is a weak acid, and then Hydrochloric acid. Okay.
Okay.
Okay. Assume that more the acidic, lesser will be the pH.
Yeah.
Okay.
Acidic
What should be the
acid.
answer for question number 14?
It's option number D.
Second, fourth. Higher the pH, weaker is the pressure. Lower the pH, weaker is the base. Yes. Question number 17.
Vanilla essence can be used because they can smell it instead of seeing it.
Yes, vanilla essence. Question number 19, sorry.
Lime juice is acidic in nature.
Lime juice.
Yeah.
Which of the following is not mineral acid?
A mineral acid.
Mineral acid means strong acid.
Strong acid. Option number B, citric acid.
Option number B.
Yes.
Yeah, it is citric acid. Hydrochloric acid, sulfuric acid, nitric acids are strong acid. Okay, tell me, which of the following is not a base?
Not a base. Option number B,
KOH is strong base. NaOH is strong base. Ethanol,
ethanol.
C2H5OH.
Ethanol. Okay, I forgot the
Ethanol.
formula
Okay,
for that.
C2H5OH.
Okay.
Solar is neither base nor acid.
The 24th one or the
Question number 28.
it's option number D.
Option number D.
Yeah, because if I remember correctly, it's bitter and changes the blue litmus to red because it's acidic.
Yeah, because yeah, simple the bitter and change blue litmus to red.
Yeah,
No, no, they are not bitter. They are sour in taste.
they're sour in taste.
Yeah, sour in taste.
Okay,
Bitter are bases. Okay, C is the correct option.
okay.
Next, we shall be going to discuss in detail. Next class will be very important. Okay,
Okay.
so we'll discuss more in detail. What are a strong acid and weak acid? You will be able to answer. Can you predict that what which are a strong acid and which are weak acid? 41.
Which are